Is my mic on? Does that sound good? Everyone can hear me all right back there? Thank you so much, everyone, for coming to my talk and waiting. My name is Huyen Tue Dao. I am a Kotlin developer, obviously. Very particularly, I'm an Android developer. And I'm here to talk to you this morning about one of my favorite subjects, the standard lib. I have a lot of content to go through, so I apologize for ahead of time because I'm a really, really, really fast talker. But I'll try to not kind of blow past everyone too hard as I talk about the standard lib. So I've actually think that this November will be my second anniversary doing Kotlin for the first time. And I think even now, one of the biggest things that I'm still trying to work on and grow and learn about is how to write idiomatic Kotlin, and stop writing, as someone who came from a Java background, Java code in Kotlin. And kind of one of the biggest ways that I've learned how to write more idiomatic Kotlin is by using the standard lib. Now, I don't just mean that I'm using the standard lib methods, which of course is idiomatic as well, but actually looking inside of the standard lib and trying to take cues from what JetBrains is doing in that lib to figure out, like, what are the cool language features I can use? What is the cool syntax that, how do they make this really awesome method work? Like, what's the magic? And so that's what I want to talk to you all about today. We're going to look at standard lib methods, we're going to look at some source code, we're going to look at some bytecode, and we're going to try to kind of figure out what is it that makes the magic in the standard lib and try to steal some for ourselves. So the first thing that I really fell in love with in the standard library is the collections API. So kind of coming from an Android Java background, probably like some of you, I've had a lot, I've worked with ArcsJava, there's now Java 8 streams, and what I really loved about that collections API is that kind of familiarity, right? Those utilities and operators that kind of remind you of how, like, those kind of fluent, streamy-like ways that you do things in ArcsJava and Java 8 streams now. And what's really neat is that the collections API is a functional API. And so what I mean by that is that it kind of has this, this functional style, this functional programming, way of kind of providing you these APIs. And I'm not going to talk about functional programming too much right now. There's actually going to be a really great talk by Raul Raja Martinez later that you should definitely check out on functional programming in Kotlin. But just really quickly, the idea of functional style, functional programming, is that you kind of approach a problem by evaluating expressions rather than focusing on specifically executing statements. And you'll often hear it explained as you focus on the what and not the how. And I think you can really see that in the collections API, right? You can see kind of like very specific high-level operators and that you can chain together, and you can almost like kind of write a story about what your code is doing. So before I go on, I just want to mention that kind of one of the really great resources that I've been reading that kind of helped me with that is this really great book called Functional Programming in Java. But it's written by Venkat Subramaniam, who is giving 2 talks at KotlinConf, which I highly recommend you go to at least one. And yes, it's written in Java, but there are a lot of really amazing functional programming concepts. So I highly encourage you to check it out. So I'm actually going to borrow quite a few words from Venkat as well when I talk about the things that are amazing about the standard lib and the collections API. I'm going to say words like fluent. And what I think that means to me is that, with things in a standard lib, with like the collections API, we can write code in a very kind of fluent way, in like a natural language way. So, for example, say I'm off on a spaceship and I'm on a voyage of discovery, going off looking for new civilizations and new life, boldly going to places. And say, like, sometimes on my voyage of discovery, I have to kind of visit a planet and do some kind of little side mission, all right? I have to figure out an away team. And, I want my away team to be effective, right? I want people with different skills. So I need to pick out my away team, kind of making sure that I have the right blend of people. So if I wanted to write a function to do that for me, I might say, hey, all right, my command deck, I need to pick out, one of my command officers, maybe an impetuous captain, maybe an enigmatic science officer. I probably want an engineer in case something breaks. So let's make sure we get a good engineer who's not kind of busy repairing something on the ship. So away missions are dangerous. I might need a doctor. Let's make sure that we find a doctor. He might be a little ornery, and make sure that he's not actually a mechanic or anything. And we might want to also have some other people, the kind of nondescript people that tend to wear red shirts and that often die very much on away missions, but we need some. So we'll have to make sure that we find ones that aren't dead already. So we need to make sure we filter out the rest of the crew and find the ones that aren't dead. And just because it's going to be a tough mission, we want to make sure that they're above a certain rank. So we'll filter so that we filter over a certain kind of minimum threshold for rank. And because why not? Let's sort them by crew rank so we can find out who goes off the boat first. So I just kind of explained a lot of different kind of conditions and things that I'm thinking about, But if you look at the code, you can really understand what I'm trying to say and what the high-level concept of what I'm doing just by looking at the code. And that's the power, and I think some of the magic about these standard lib utilities and methods in the collections API. And kind of like, Andre was just talking about in the keynote, it's about readability and kind of being able to understand what's going on in a very precise way. And, readable code is more maintainable, it's less error-prone, and that's, I think, some of the magic sauce that is in the standard lib. So let's go ahead and kind of take a look at some of the standard lib methods and see what we can kind of figure out, how we can steal some of that magic for ourselves. So if we look at filter, which actually calls filter too, so let's we kind of peek around at other methods. We can see there's a lot of stuff going on. There's some things that look like function types in the parameters, there's some keywords, there's some kind of interesting syntaxes with dots and arrows everywhere. So let's take a look at what these things are and how they're able to make this magic. So if you look at the standard lib, you'll see a lot of higher order functions. So what's a higher order function? Well, if you've been doing Kotlin for some time, you've probably heard that one of the interesting things about Kotlin as a language is that it treats functions as first-class citizens, or that functions are first class. So what does this mean? This basically means that you can treat functions as values that can be passed around. So you can store functions in variables, you can pass function as parameters to other functions, you can return functions from other functions. So they're really just like other values. And so part of kind of how these kind of functions are able to exist as first-class citizens, there's kind of a few different aspects to this. So in Kotlin, there's a couple different what are known as function literals. And basically a function literal is a function as an expression. It's something that you can pass around. And if you've been doing Kotlin for a little bit, you might recognize lambdas. So lambdas are a type of function literal. They're basically, and I checked this in a few different places in the official documentation, they're basically a chunk of code surrounded in curly brackets that you can pass around. And that generally make up, function parameters to, higher order methods. So here I have a couple of lambdas. They're stored in some immutable vowels. One of them determines if a string is a palindrome. So basically it says, okay, is it the same backwards or forwards? And then I have a very simple method that determines if an integer is even. And then I have a bit of a longer method that determines the median of an integer array. And so yeah, these are all kind of function literals that are being stored inside of variables. So a few interesting things to know about lambdas is that, number one, you have your argument list, kind of, not too crazy from what we typically do when we declare functions. And we also have, the right arrow notation that kind of leads into the body of our work, body of our function rather. And then, so the interesting thing I think with lambdas, and something that you have to kind of keep note of, is what is the value, what is the return value of a lambda? So lambdas generally will take, like the value returned by a lambda is generally the last evaluated expression in that lambda. So as you can see here in my median function, I actually have several possible return values. So it could be 0, it could be just the first int, it could be some int in the middle. But you can see here I don't have any return statements. And unfortunately, if I try to add a return statement, because I generally like code being really readable, I love putting return statements everywhere, not really, but if you are that kind of person, you might be a little disappointed because you can't. You're getting the IDE yelling at you saying return is not allowed here. Now there's a lot of reasons for this, but basically the way that Kotlin treats the return statement is that it is returning from the kind of closest function declared by using the fun operator. And in this case, the lambda is not declared that way. And to return here is to return from that enclosing function. Now, the reason that's a problem is that imagine that I've kind of whatever function I'm declaring these lambdas in. Say that I take these lambdas, I stick them in a variable, and this function that I'm declaring them in kind of ends. If I call that lambda later, what does that return that was in that lambda mean? The executing context that it was created in is gone. So that's kind of partly the reason why you can't do this. But there is kind of a little way you can return from lambdas like this that have multiple kind of exit points, and you can actually do a qualified return where you actually give the lambda a label, and then you can do this qualified return inside of the lambda. So that is there for you if you are kind of like the returny type. So the kind of using of that return statement is known as a non-local return. So just to remember, lambdas in general lambdas do not in general allow non-local returns. So lambdas, they're these wonderful little function expressions that can get passed around. How does it work? So I'm going to prove to you that lambdas are not magic, and that there's some really very understandable ways that Kotlin is actually creating these lambdas. And to do that, we're going to take a bytecode break and take a look at some bytecode to figure out what exactly the compiler is doing with these lambdas. So I am going to open up a separate file. Okay, so I have a lambda. Can y'all in the back see that okay? I apologize. It's a bit small. You all right? Okay. So here's a lambda. It's actually just a very simple average method. I have two integers. I'm adding them together and multiplying by 0.5 to get the average value. So what does that look like in bytecode? So there's a lot going on here, and generally I like to cheat. I like to decompile the bytecode back into Java because it's easier for me to read, but we're going to go ahead and be brave and kind of look at the bytecode. So if we scroll down just a little bit, here is actually that average method. So what's going on here is that the average lambda becomes an inner class. Here it is, bytecode lambdas like $average.class. So this is the class that my lambda becomes. So each lambda actually gets compiled into a class. And if I scroll down a little bit, so this class actually extends function2 since it has two parameters. It becomes a subclass of the function2. And as you can kind of see here, this is actually where the average is being calculated. So I'm loading up my two parameters, I'm adding them together, calling some other nice instructions, loading 0.5, and then doing some multiplication and returning it. And the other thing to note before we leave off is that there's actually, despite the fact that this lambda is becoming a class, there's actually a single instance of this class, of this lambda, and that's right here, this capital instance. So I'm mentioning that because if you're like me and you're generally pretty scared of Java instructions and looking at them, if you decompile the code and look at the kind of more Java-y bytecode, you'll end up seeing this a lot with lambdas, null.instance. So it doesn't really tell you a lot, but basically, as I understand it, a lot of times when the bytecode is kind of decompiled, because of all the inner classes that get generated, a lot of times the decompiled code will omit some of those internal classes just for brevity. So if you're ever looking at the bytecode and are confused by that, that's where that comes from. And I have to give a big hat tip to Victoria Ganda, from whom I learned that little tidbit about null.instance. She actually gave a talk last year at KotlinConf called Understanding Every Line of Your Code Base. And she also has given some other great talks about kind of looking at bytecode and trying to understand like what's going on there under the hood, and I would highly recommend them. So let's get back to talking about higher order functions, and let's talk about how we're able to pass functions as parameters and return functions as values. So, all right, so in the course of maybe building an app, we like to track events, right? We want to see what our users are doing sometimes. And maybe say we want to sometimes track to a log, sometimes we might want to write that log out to a file, or write those events out to a file, or maybe we have some kind of cloud service, right, that's aggregating all these events. So say I want to kind of set up my event tracking, and I might want to send my events to any of these destinations depending on what I'm doing. And I might write something like this. I might have 3 lambdas that kind of encapsulate kind of each type of destination I can send my events to. And I might have an enum here, like this enum destination, that basically is kind of a way for me to describe where I want my events to go. And I might write a method like this that maps an enum value for the destination to an actual lambda that I'm going to call to send that event off to its final resting place. And I might have a method here, somewhere in my code that actually allows me to pass in a tracker. We don't care exactly which one. We just want to know that we have a tracker that we can send off events to. So I might do something like that. Now, as you can see here, this tracker is actually a higher order method. It doesn't take any functions as parameters, but it's returning one of my previously defined lambdas that allow me to call it later on here. And with lambdas, as you might know, you can call them either by kind of through traditional function call syntax, or you can go ahead and actually call invoke on that lambda object and then pass in the parameters that way. And this is all great, but there's actually some other things that we can do. So you're not always tied to kind of creating like functions in this way. Like you can actually pass around function references. So it's not just the lambdas and the function literals that get to have fun. Declared functions can kind of join in the party as well. So say I have these 3 lambdas and I don't actually want them to be lambdas. I prefer them to be declared functions. So if I just go ahead and turn these into methods by doing that, we're going to go ahead and close up this argument list, and we're going to go ahead and replace val with fun. Oop, and then fix the little that's going on. All right, so instead of 3 lambdas, I now have 3 declared functions, and of course, unfortunately, GetTracker is not happy because now my lambdas are gone. These aren't really, function literals anymore. But if I add in the double colon, that actually allows me to grab a reference to a declared function, and then, great, so I can actually still pass along functions as parameters, or return functions as values, rather, even with declared functions. So really, really great stuff. All right. So there's one more type of function literal, which I personally have never used that much, but I kind of recently learned about, which are anonymous functions. So there's some interesting properties of lambdas. So if we're looking at this lambda here, so I've got two function literals here. They do the same thing. They're looking at a file and determining, is this a character file, basically just looking at the extension and seeing if it matches. So the first one is a lambda. It's kind of the familiar syntax with the curly braces, the argument list, and it's just assigned directly to a value, to a val. So some interesting thing about that lambda is that generally you don't specify return type for lambda, they're just inferred. Whereas this down here, this anonymous function is a bit different. So an anonymous function is declared very similarly to a regular declared function. You just omit the name, and that actually becomes a function literal. It's an anonymous function. So anonymous functions allow you to specify the return type, if that's handy to you, and also they also allow you to use that return statement, because return statements allow you to kind of exit out of the kind of most recently declared fun, and there it is, the anonymous function. And this, when it comes out in the wash, anonymous functions come out in bytecode just like lambdas. They become an internal class and possibly an instance, sometimes not, depending on what's going on. But they're kind of just another flavor of function literal for you to use. I actually haven't used them that much. If anyone's used function literals and can come up and can tell me a really compelling case where you always kind of default to anonymous functions, I'd love to hear it. But, okay, so we've talked about function literals. Let's talk about something more familiar, something a little bit less abstract. So, standard extensions. So I think immediately after I fell in love with the collections API, I fell in love with standard extensions. And what I mean by standard extensions are all those little awesome methods in the standard lib, like apply and let and run, and also that kind of, allow you to play with scoping, allow you to kind of represent different things that you're doing in your code differently. So, for example, I might use apply to do some initialization on an object. I might use also to represent some side effects that are going into my code. And I might say use run to indicate some kind of action or behavior that's kind of just getting fired off. And so these are kind of like, hopefully if you've been using standard lib a bit, something that you've been really diving into and figuring out and trying to use in your day-to-day Kotlin life. So, let's take a look at these extensions and see what we can learn about how they're built to see how they do what they do. So just to warn you, I'm not going to talk about when you should use apply versus also versus let versus run, but last year at KotlinConf there was a really great talk by Christina Lee called Two Stones, One Bird, Implementation Trade-offs, where she talks about this exact thing. So you should totally go look that up. If you're like me and sometimes at 2 a.m. in the morning can't decide whether you want to apply or also, it's a really good resource. So when I'm kind of analyzing these standard extensions and trying to learn things about Kotlin through them, I generally try to kind of categorize them and kind of determine kind of different features that they have. So the questions I ask myself when kind of asking myself, one, which one do I want to use, and two, why do they work the way they do, is number one, is it an extension function? And I'll explain what that is in just a second. Number two, does it return the receiver or a new value? And number three, do you pass a lambda or a lambda with receiver? And I promise I'm going to explain what all these things are if they're unfamiliar terms to you. So let's first take a look at the source of these standard extensions. And I'm going to cheat a little bit. I'm actually going to copy and paste it here. So we have run, we have with, we have another run, we have apply, also, and let. So let's take a look at my 3 questions and kind of try to analyze these methods through those 3 questions. So number one, are these, which are extension functions? So you can tell when a function is an extension function because you'll see a type, the dot operator, prefixing the name. So as you can see here, run, apply, also, and let have the dot operator, and this type parameter t beforehand. So that is actually indicating to you this is an extension function. And so the second question I ask myself when I'm looking at these methods is, okay, does it return the receiver or does it return a different value? So if you look at, say, apply right here that I've already had highlighted, it's actually returning t, which matches both this kind of extension t here and this other t here in this parameter that I'll talk about in just a second. In that case, we can see that apply is actually returning the receiver. Now contrast that with let, where it's actually returning a different value of type r. So it's returning a different value. So it's like another way I try to differentiate the 3, all these different standard extensions. And finally, the parameter that is passed to these standard extensions, is it a lambda or is it a lambda with receiver? So lambdas with receivers look a little bit like this. They kind of echo that kind of syntax we have with the extension methods, or extension functions rather, where we have a type, the dot, and then the actual argument list. Whereas a regular old llama looks kind of like a regular function type here with just the parameter list and then the return type. So let's talk about extension functions. Extension functions are kind of one of my favorite things in Kotlin, and they're really awesome. So if you've been writing Java, you probably have at some point in your life written a string utils file that has a whole bunch of things that you need to do for your project to process strings. This is actually something I did for work. This is a method that removes diacriticals, which are basically more or less accent marks, on characters. And I had to do this for work to do some searching, and so I wrote a method, a nice string utility method called remove diacriticals. And then to call that in Java, I would do the typical thing that you might be used to, where string util dot remove diacriticals, and then pass in my string that I want to strip out. So that's all well and good. It's fine. We've probably done this a billion times. But the really nice thing about Kotlin is that it allows us to do these things in a much nicer way. We can write these utility methods and actually treat them like they're extensions, like they're added behavior on top of classes without having to, number one, subclass those classes or actually have ownership of that class. So if I wanted to write this remove diacriticals utility in Kotlin, I would do something like this. So I have a regex here that does all the kind of magic of removing the diacriticals. But then I have here, it's an extension function. So I have my function name, and then of course I have it prefixed by the dot operator and the string type. And then I just have the rest of the contents is normal, and that's it. And what's really neat about this is that, let's see, if I wanted to call this, there we go, like this. All right, so when I actually call this method in wherever I'm needing to strip out those diacriticals, if you look here, it looks just like a member method on that string class. And that's the power of these extension methods. It's allowing you to basically extend functionality without actually having, again, to subclass or have ownership of the string class. And just these little things, it seems like not a big deal, right? Like there's not a lot of difference between calling string utils dot, whatever my utility method is, and this. But it's all these kind of little syntaxes, all these little kind of niceties, all these little ways of making the code more fluent that add up and that allow us to create this really readable, much more maintainable code. So, and we're going to take a bytecode break and see how these extension methods are actually, compiled down from Kotlin. So, if I want to take a look at a extension, so this is basically the same method I just had. It's just got a little bit different name for collision. And if I actually look at the bytecode, and I'm going to cheat this time and compile it down to Java, you can see that the implementation here is kind of just a static, utility method, just like I had before. And so you can be assured that, there's no extra kind of performance impacts or anything. You're basically doing what you've always been doing in Java, but in a much nicer syntax in Kotlin. So again, all these little things, this is just one of those little magic tricks that allows the standard lib and some of those APIs to be as nice and friendly to use and as sexy as they are, right? And so now with Kotlin, we have all these wonderful string processing methods like is null or empty, ends with, code point counts, filtering, and they're all done the same way. These are all extension methods, and you can see that just by clicking through. There's my extension function syntax, and it's kind of really cool because just imagine all these utilities that you can do too, all this extending of functionality that you can do on your own with this really great syntax. So lambdas with receivers. So lambdas with receivers are pretty interesting. Lambdas with receivers basically are extension functions, but for lambdas. So with kind of extension functions, I'm taking a utility method that takes one or more parameters and basically saying, okay, instead of actually having a utility method where I just pass in parameters, I'm going to take one of those parameters, like my string, for a string in my string example, and kind of elevating it and giving it superpowers. And it becomes this inside of the method, right? I'm able to call things on that object without qualifying it. And basically, lambdas with receivers do the exact same thing. In terms of just the lambdas as function literals. So say that I'm an unscrupulous science company and I'm writing this, because everyone has to have, machine learning and AI now. Say I've written an AI that will run tests on subjects, and I'm sorry that got a little bit dark, but this is the example we're going with. So say I have this really morally not great AI that's going to run tests on test subjects, and it can do a number of different things, unfortunately some involving neurotoxin, but some involving cake. And say that I actually wanted to kind of enumerate a bunch of test suites that I want my very scary AI to run on some poor suspecting subject. I'm really sorry about this example. It's very mean. But I might actually kind of write these tests suites as lambdas per se. So maybe I have one lambda that just runs through a bunch of tests. And maybe say I have one lambda where I run one test on a subject, and if they do well, I congratulate them. If they don't, I make cake. I don't know, I think I'd rather have the cake than encouragement, but that's what we've got. And so maybe I have a higher order method that will run one of these blocks, one of these lambdas, one of these test suites on a subject. So it might look like this. So I pass into my method some version of my AI that I want to run. I pass in the name of a test subject, and I pass in some block, some test suite that I want to run the subject. And so I might instantiate the tester, and then I'll just go ahead and call my lambda, passing in both the tester object and the subject name. And then that will actually run whatever test suite that is on my subject. And that's all well and fine. There's nothing wrong here. It works. But there's some really neat things that we can do when we make this a lambda with receiver. So first, let me show you how to turn these lambdas into lambdas with receivers. And like I mentioned before, it's all about taking a parameter and kind of giving it superpowers and elevating it. So here in my higher order method, I'm going to change the signature to be a lambda with receiver. So I'm going to take AI tester out, and I'm going to make it the receiver. So this is now the receiver type. It's going to become the this inside of the lambda. And what's interesting is that regardless of whether a lambda is a regular lambda or a lambda with receiver, you can still call it in the same way by calling the parameter name and then passing the receiver as the first argument. But if you want to go a little bit better and kind of use kind of more regular function call syntax, you can actually call it like this. So because my tester is now my receiver object, I can call the lambda on that receiver as if it was just a member function. Now, if I wanted to change my lambdas up here to be lambdas with receivers, then I can go ahead and again move out the kind of tester to be the receiver object. And then I'm going to go ahead and close up the argument list. And I'm going to take this out since the tester no longer exists as a parameter into the lambda. And now I have lambdas with receivers. But I have a little bit of complaints because now that the tester object doesn't exist, I need to get rid of those. So boop, boop, do. And here. All right. Oop. One too far. There we go. All right. There we go. All right. So as you can see here, one of the really fascinating things, again, I can call the methods inside of these just as if, I was calling them directly kind of on the AI tester without any kind of qualifications. And so that's not a big deal, but again, it's kind of reducing some of that visual noise. I mean, how many times have you written a method and had to say object this, object that, object this, object that? So again, it makes it just slightly more readable and slightly more maintainable. And there's other things that you can do with this. So if you look at kind of my two test suites here, I'm always doing something at the beginning and something at the end. I have to activate my AI and then deactivate it. And what you can really leverage lambda with receivers for is to use really interesting design patterns. So kind of referring back to Venkat Subramaniam, who gave a really amazing talk about design patterns with lambdas. He kind of talked about this design pattern called execute around method. So a lot of times when we do something, say open like input or kind of input, read input from a file, say, or maybe kind of database, right? There's always something we do at the beginning. There's always something that we have to do at the end. But what we really care about is the stuff in the middle, what we're actually doing. The rest of it is, and I love this word, ceremony, right? It's stuff that you have to do, but that isn't the focus of what you're trying to do. And lambdas with receivers will actually allow you to kind of abstract away that ceremony. And again, write kind of less error prone, more readable, and just more fun code. So if I do something like this, where I actually, instead of specifically calling kind of that ceremony in each of my individual lambdas, I can actually go ahead and insert that kind of ceremony inside of my higher order function. So I actually kind of delegate away all that ceremony to my higher order function, which I trust to do kind of all that. And then if I actually wanted to call that method, you can see here that I can, so now I can pass in a lambda, and I don't have to worry about the ceremony. And again, like lambdas with receivers making something like this, yeah, it's a little bit nice in syntax, a little bit like less noise, but again, you can build these really cool constructs that, again, help you make better code by kind of looking at some of these really interesting techniques in the Kotlin language features. So again, execute around method, you can actually see it in other places. If you kind of remember try with resources in Java world, where it helps you with, again, managing like kind of input streams and doing all the cleanup with the finally and everything like that, there is an analog to that in Kotlin called use, and use is an execute around method. It takes care of all that ceremony and allows you just to focus as you're writing the code on what's important, what you're actually trying to read or write from that file or stream or whatever. So lambdas with receivers, all sounds really amazing. The syntax is really great. are there trade-offs? Yes. And to talk about trade-offs, let's talk about closures and captures. Oh, there we go. I could type. Wait, I know. There we go. All right. So, what are closures and captures? Well, a closure is, and this is a direct definition, a closure is the combination of a function and lexical environment within which that function was declared. And it took me a long time to kind of actually grok that. So what that actually means is, say you're declaring a function, right? And oftentimes when you're declaring that function, there's going to be local variables that that function can see and can access within its defining scope. So those local variables within scope of that function are your environment. And when a function you declare actually kind of reaches out and accesses those values and uses them, the function closes over those scoped values. That's why it's called a closure. And those values that are actually being used by that function in that closure are referred to as being captured. So if you think back to Java world and you think about anonymous classes, you know, a lot of times when you're kind of defining anonymous classes, you can reach out and use other values, but they have to be final. It's kind of that same thing where, you know, it's related to this because Java, the way that Java works, it has issues sometimes with the compiler and having like mutable variables. That's why they'd be final. But, okay, why does this matter with Kotlin? Well, it matters a lot when you have these captures to how efficient lambdas can be. So in order to show you how efficient lambdas can be, I have here a little example. So I'm back off of my voyage of discovery again on my ship, and then something terrible happens, and we have to self-destruct the ship. Maybe we have some aliens coming on board, and they want to steal some kind of amazing technology or weapon. All right, that's it. We're going to get GTFO, and we're going to go ahead and self-destruct the ship. So I have my ship's computer, and it has a higher order method, which I can use to run commands. So here I have the ship's computer running commands, and I give it a lambda. I need to get crew authorization from some, senior officers, and then I have to actually initiate the self-destruct sequence, and then have to get everybody off the boat. So I'm actually going to read this real quick. So, all right, when I talk about trade-offs with lambdas, what do I mean? So in order to tell you that, we're going to take a little bytecode break and check out what this looks like in the bytecode. So if I open up the bytecode, decompile it because I'm a chicken, and take a look at the Java code. All right, so what I have down here is, nothing too crazy, right? We saw this before. This weird little null.instance means that that lambda that I created and passed to my ship is just a single instance. It's an internal class, but there's one instance of it. But if I go back and say I have here, I can pass in how many seconds that I want the self-destruct to be delayed by, because we probably want to delay it if we want to actually get people off the boat. So say I actually kind of reach out inside of my lambda and grab that seconds till value. What does that do to my bytecode? Well, it does a little something like this. And as you can see, oh my goodness, it's no longer an instance. What's happening is that now every time I run that method, I'm creating a whole new instantiation of function one. And there's all kinds of other nasty sounding things like synthetic methods and bridge methods. So just from wanting to kind of access an outside value, I basically have kind of increased kind of like the, the object, cost of that lambda. And so, in isolation, one of these might not be a big deal, but imagine this is running in a loop that runs 1,000 times, or you're just calling this method over and over and over again. These will add up. And while, it's important to kind of, again, use these features to write good, readable, maintainable code, it is important to be aware of the costs, because there are some. So there are ways, though, to mitigate these costs. So how much time do I have left? What time is this session over? 11? Is that right? 11? Okay. All right. So we can reduce some of the penalties of lambda through inlining. So when you inline a function, basically, when you inline a function, anytime that function is called, it actually gets replaced with the body of that function. You can imagine as the body of that function basically gets copy-pasted to wherever you call it. And what's really cool in Kotlin is that you can inline higher order functions. Now what happens is when you inline a higher order functions that's taking in other functions as parameters, both the function itself gets inlined, and so does each of those lambdas that you pass in. And we're going to have to take a bytecode break to see what this looks like. So if I open up some inlined code. All right, so this is a little bit different. Say I'm working at a kind of scary children's restaurant that might have animatronics. Sometimes the animatronics might walk around and kind of do scary things. Sometimes they just kind of hide around and just scare me. I'm working this shift as security guard. I don't know why, it's the worst job in the world. But there's certain things I have to do in my shift. I might need to kind of, I don't know, close doors, make sure that the animatronics don't get me, or I might just have to kind of watch security cameras and make sure everything is all right. So I might do something like this if I wanted to program that in Kotlin, where say I have a higher order function, work shift, and my work shift takes a couple parameters. One is the location where I'm working, and second is a block. It's, say, whatever sequence of events I decide I need to do for that work shift to, let's say, survive the night. And so I might end up calling this something like this. So I have my work shift higher order function. I pass in a parameter, and then I actually also pass in, using a very nice like lambda outside the parentheses syntax, pass in this other lambda where I actually am kind of specifying the things that I'm going to do on my shift. So if we look at the bytecode for this, you can see that, all right, well, that looks kind of like how you would expect it to look, right? So here's my method, here's it being called in main, and it's really just calling to that work shift function. Okay, no big deal. All right, so what if we added the inline keyword before work shift? What does that do? All right, so we go back to the bytecode, decompile it, and we look, and hey, so that's kind of interesting, right? So what the inline has done is that it has, in fact, taken that lambda that I declared and taken that body and just copy-pasted it where I actually called the method. And so again, this allows you to come circumvent some of those costs, like the inner class and that extra instantiation or more, depending on how the lambda is structured. So again, even though there is cost, there are ways you can circumvent it depending on what your needs are and what you kind of can do with your code. Also, something really great about inlining is that, kind of remember before when I said that you can't do non-local returns from lambdas? You kind of can, but you have to have an inline function. So let's pretend that this isn't inline at first. And let's say in my lambda, I'm just going to go ahead and check how much battery I have left for all the things that are going to keep me from getting, attacked by these weird animatronics in this child's restaurant, and say, if I don't have enough battery, I'm just going to leave. I don't need this job. Let's just get out of here. But unfortunately, it's going to have a compiler error because this is lambda and returns are not allowed here. However, if your lambda, or rather if your higher order function is inline, you can do a non-local return. And because of the fact that the body of that lambda gets copy-pasted, you don't have to worry about that return getting called way later when that execution context is over. It's getting called now. So that's one way also that you can get away with doing non-local returns inside of lambdas if they're inline. So now there's a couple other really interesting keywords related to inline and that kind of allow you to kind of be a little more flexible. So as I mentioned before, when you inline a higher order method, everything gets inlined. So any lambdas that you pass to it also get inlined. Now that might be fine, but that also prevents you from actually working with those lambdas as function literals and passing them around. So if I did something like this, where I have an inline method here, where I have a lambda, you can see here that it's actually having a compiler error because you can't actually treat the inlined, the parameters of the inline like a lambda. But what you can do is, if you kind of need to do that, if you still want to have your higher order method be, say, partially inline, but still be able to treat some of them like function literals, you can use this no inline keyword, and that specific parameter will not be inline. So you can actually go ahead and use it like a regular lambda or other function literal, save it, pass it around, whatever you'd like to do. So you might have seen cross inline, and this is one of those things that took me a really long time to understand, but it's pretty important. So a lot of kind of like the caveats about working with lambdas and kind of again like with non-local returns is basically the idea of, okay, am I going to be put in a position where my execution context is gone and I'm trying to return from something that no longer exists? Now here I have an inline method, so technically I should be fine to call a return here, right? Well, I can't because of runnable, right? Runnable usually we instantiate because we want to run something later. And what happens here is that, say, I have here in this method 2 parameters that are lambdas. I can do a local return from this one, but if I try to return from this method, I actually get a compiler error. And it's able to say that, hey, you're putting this body is getting inlined inside of a runnable. So that means that you could actually be out of this execution context, so you can't return here. And if I try to cheat and try to say, okay, well, what if I do this? Again, it's like, no, I see what you're doing there. You can't do that. So again, if you're kind of in this situation where, you kind of are having kind of like inline, but also like say something with runnable or something that otherwise is also executed later, cross inline is there for you. So let me go ahead and just, but again, like the cross inline allows you to kind of reinforce, that kind of non-local return in that situation. So something else that is really cool with inline is reification. So when you have a method that is like a generic method, a lot of times, and I'm sure I know I've done this, is that I've really wanted to do a check against that type, but because of the way that generics are implemented in Java, that type of information is available at compile time, but it gets erased at runtime. So you actually can't do this in Java, but you can in Kotlin with inline functions. So I have this inline function. Now, normally, again, I can't do this because of type erasure, but there's actually a keyword, reify, that I can add to an inline method to that type parameter, and it basically lets the compiler know that I want that type information available at runtime, and it'll kind of do a few magical things with the bytecode, and allow me to check that type within my method like this. So really cool trick. Something to be aware of, though, that reified inline methods cannot be called from Java. You can call normal inline functions, but they're not inline. They're just treated as regular functions. So kind of trying to wrap up, I just think so there's a lot of keywords and kind of all these kind of interesting syntaxes, but I just think there's just so much really delightful things in the standard lib that, that at first seem kind of magical, but then now you look at it and it's like, oh, I can do that too. So something I thought was really neat was when I first learned Kotlin, I saw, okay, there's this to operator that allows me to create a pair from two variables. That's kind of cool. And I actually distinctly remember trying to look up to Kotlin keyword and not being able to find it. And the reason that it is because it's not a keyword. It is a method. So as you can see here, to is actually a method, but I'm somehow able to call it without a dot or parentheses. And that is because of infix. So infix is basically just this language feature where if you have a parameter, if you have a one parameter class method or extension, you can actually call it without the dot or the parentheses. And if you've kind of done stuff with ranges and used down to, if you're like me and you really, really missed shifting bits and you were so glad to see that shift right operator, it's not an operator, it's just an infix function. And what's really cool is that you can use this yourself. So I'm back again on my voyage of discovery, and my captain tends to log things. He's just likes to monologue and just explain what's going on with his day. I might write an extension method like this that allows my captain to kind of start his star log or log his particular star date. And I could certainly, call this start log method in the usual way, but I can also, since it's a one parameter method, give it a little infix keyword, and I can actually call it like this. So I know it's not a huge deal, it's kind of silly, but imagine, again, the power of being able to use this in situations where you can make the code more readable, more fluent, more kind of high level. You can really describe what you're doing. And that kind of leads me to another thing that's really cool about Kotlin, and it's this idea of conventions. So many of these cool, sexy, syntaxes that we get in Kotlin are done through, things like infix, but also through this concept called conventions. And basically, conventions are a way of accessing Kotlin language features via particular naming scheme, as opposed to, say, extending a class or an interface. So something that is so awesome to have in Kotlin is operator overloading. And so here I'm in a different world now. Now I'm leading a ragtag group of adventurers trying to save the galaxy from a cosmic darkness, and now I'm trying to build my squad to save the galaxy. And here I can very easily use a plus equals operator to build up my squad, and I'm able to do that through operator overloading. And it's not magic, it's actually done through conventions. So inside of my squad class, I have here a very specifically named method plus assign. And if am able to have a method with this name and prefix it with operator, I'm able to actually, again, use this overloaded operator inside of my code. And it's just kind of awesome, right? Being able to use these kind of high-level, readable kind of constructs and use them for yourself. So I'm running out of time, but other things like destructuring declarations, if you've ever tried to been able to pull properties out of an object and directly assign them to variables, that's also done through conventions. Delegates are also done through conventions. Basically, if you want to circumvent the typically generated setters and getters and kind of either make reusable logic or do some kind of fun things, those are done with conventions. Okay, now with the time left, I want to talk about something new and awesome, and that's contracts. Contracts are actually not quite yet out. They're 1.3 and they're experimental. And I think they're really amazing, and again, it's just going to be another awesome tool in the toolbox to create really cool things in Kotlin. So I don't know about you, but I've run into this situation many, many times. So I have a method here. It has a nullable parameter, And I'm actually going to do a precondition check on this. I'm going to require null, right? And that way, I'm going to just go ahead and just crash, whatever I'm doing if it's not null, because it really should not be, right? So that's all good. I should be good here. I'm going to crash if it's null. But then for some reason, actually, hold on. If I was on 1.2, since that's the actual what's in production right now, you might actually see something like this. So even though I have written a statement that specifically says, get out of here if sphere is null, I still have the compiler complaining at me that, hey, this is nullable. You should put a null assertion or a null safety operator here. And that's like really frustrating to me because part of like the nice things about Kotlin is like smart casting and being able to like smartly use null safe kind of code. But again, if we go back to 1.3 with contracts, I'm actually able to do this because what contracts are basically ways of telling the compiler how a function behaves. Like, what is it actually doing? And if I click into require not null, and you can actually see contracts now in the standard lib, you see this little contract construct here. And it says that when this method returns, then it automatically implies that the parameter is not null. And so that is giving the compiler the information it needs to be able to do the smart cast. And once 1.3 comes out, or if you're on experimental like me, I forgot to turn it off for your presentation, you can do really cool things with them. And there's other situations that you might have popped up for you that might have kind of run into something where you really want to use contracts. This actually happened to me at work, not exactly like this, but basically I had a Lambda and I wanted to assign a val from that Lambda, and it was totally fine. I just had this one value that I needed to initialize, but I couldn't do it within the Lambda. And the compiler error that I got was captured values initialization is forbidden due to possible reassignment. Now, the reason the compiler doesn't like this is that in my higher order function here, the compiler is saying, hey, I don't want you doing that because what if you actually, let's say, called the Lambda twice inside that higher order function? Then, you'd be trying to assign a immutable value twice. So that's why I actually got that, that's why you have this error here. But, once we have 1.3 out and we are able to have access to contracts, you can do something like this, or you can actually say, wait, first let me get on 1.3 and get the API. Okay. So I can actually go ahead and add a contract in place. Okay, but it's experimental, so I'm going to have to add annotation here and annotation here. And hey, so I'm able to say, look, compiler, I promise you this is only going to run once, so you never have to worry about my values, my immutable values being assigned twice. And I just think this is so cool, right? Again, this is just more tools that you can do to write your own sexy, awesome, fluent, utilities to make really beautiful, readable Kotlin code. And so I encourage all of you to go out to that standard lib, look inside, try to figure out what all these weird constructs are, copy it, rip off the standard lib, and do your own cool things. And it can teach you so much and help your Kotlin become a little more idiomatic. Thank you so much, everyone. Sorry for running over, but thank you so much, and enjoy KotlinConf.